Chapter 8, Binomial Geometric. First off, we got to remember what a binomial setting is. In a binomial setting, first off, you need to have two things. It can either be a success or a failure. Next, we have to have a fixed number of observations, and this is the big idea in a binomial setting. And we have to have all of the observations be independent, and the probability P has to stay the same for each observation. So if it meets those four criteria, it's in the binomial setting. So let's say a couple has 5 children. The mother says has type O blood. The father has type A blood. What's the so there's a 25% chance that each kid would end up with type O blood. What's the probability that exactly 2 kids have type O blood? So we could fill in a probability distribution, but let's just fill it in for 2. So we have 5 children. We do a combination of 2. And the probability that they have type O blood is 0.25, and 2 people are going to have that. The probability they don't have type O blood is 0.75, and there's going to be 3 of them that have that. So then we type 5, choose 2 into the calculator, and I believe that's 10. Yep, and then so it's going to be 10 times 0.25 squared times 0.75 to the third power, and that'll get us that value. And so on and so on. But, there's a nice way to do this on the calculator, where they have a nice little distribution of binomial already figured out for us. So we do a binomial Pdf, because this is probability distribution, and we put in our n value of 5. Our probability of success is 0.25, and then our value here is 2. So when we put that in, we can see that the probability this happens is 0.26. And now if we want to find the other probabilities, we can just hit second enter and just modify that last number to say 3. And now we can find the probability that 3 people have type O blood. We can see is 0.087. Well, let's just say 0.09. And you can do the same thing to fill out the other values. Now, this is the equation that AP gives you for binomial probability. Now, this NK is another way of saying N choose K. So keep in mind that those are the same two things. The probability of success to the K, and then the failure to the N minus K. Now, PDF means we're finding each probability. A CDF is a cumulative, meaning that you add the function as you move to the right. So if I do this one here, it would just keep adding up 0 and 1 to get this value, 0, 1, and 2 to get this value, 0, 1, 2, and 3 to get this value. And so in the end, it should, a cumulative will add up to 100%. The means and standard deviations of a binomial situation are given to you in AP and on my exams. So that's how you find the mean, that's how you find the standard deviation. To do a normal approximation, this is the first time where we have to do n times p is greater than 10, n times 1 minus p has to be greater than or equal to 10. And if it passes both of these situations, we can say that it's a normal approximation and use that. So if I want to find the normal approximation for this problem, first thing we do is there's 2,500 people, and the probability of success is 0.6. So the probability of failure is 0.4. We check to see that both of these values are above 10, and it's going to be way above 10. This first one is 1,500. That's way above 10. This other one is 1,000. That's way above 10. So that tells us that we can use the normal approximation. This says what's the probability that 15, 20, or more? Get a little excited there. So probability x is greater than 15, 20. And so then we have to find the mean. The mean is n times p, so which we already found out to be 1,500. Now we do the standard deviation, which is n times p times 1 minus p. So, and then square root that answer, which would be 24.5. So I'm going to take the probability that my z-score is greater than 1520 minus my mean of 18 or 1500 and divide that by my standard deviation, which is 24.5. And now when I do that, I get the probability that my z is greater than 0.816, and the probability that that occurs is going to be 0.207. So there's a few parts here. That's why problems like this are a lot of points. You have to write out your probability, figure out your z-score, and then find this probability. But before that, you have to find mean and standard deviation and check to see if we can use that normal distribution. So if Karine makes 75% of her free throw shots, assume that each throw is independent, find the probability that she makes exactly 3 out of the 12 shots. Well, we have 12, choose 3. She makes 3 shots. That means she doesn't make 9 shots. You plug that into your calculator, or you can do Binomial Pdf of 12, comma, 0.75, comma 3, and you'll see that this is a very small probability. Now a geometric setting is pretty much everything's the same, but now number 4 is different. The variable of interest is the number of trials required to get our first success. So now we're not dealing with a fixed number of trials. We have to keep going until we get our first success. When we want to calculate the geometric probabilities, you'll have one success and a whole bunch of failures. There'll be the failures will be one less than the number of trials that you did. And there's another formula, the probability that it takes more than 4 times to get something geometrically is the amount of failures to that number. So say if the probability that I trip and fall in class is maybe I don't know, 1, 2, the probability that it takes more than 8 days for me to trip and fall in class is the probability of 1 minus 0.12 to the 8th power. So that's going to be 0.88 to the 5th power. So the probability it takes more than 8 days for me to trip is 0.5277. So there's about a 53% chance that it'll take more than 8 days for me to trip in class, given that the initial probability is 0.12. All right, hopefully that helped out, and you'll be ready for Chapter 8 stuff.